So yesterday we were discussing about the structures, the different structure, the data type structure. Why we use the data type structure? It is to incorporate different data types into a single name or into a single single data structure. In the case of arrays, you have multiple data elements can be stored, but the only difficulty in that case is all the data elements should be of the same type. No two different types of data can be stored in an array. But in the case of structure, different types of data, different data types can be stored. As we have seen in an example structure, in this case there is a structure, it starts with the structure definition always starts with struct, that is struct. This is a keyword struct. Then the double braces starts, then the elements or the members within the structure are defined, and the members within the structure are defined as in the same way as we define the different identifiers in C program. So that is like int number. So we are defining a variable number as of type int, data type is int. Then there is char title 30, so it is a character array, and the size of the character array is 30 and the name of the array is title. And there is char author 20, so it is again a character array, and the name of the array is author and the size of the array is 20. Then there is a floating float and float type value, a float type variable, that is float price. So then we close the double braces and then we give the variables list. So book 1 as well as book 2, these will be of type this particular structure, and book 1 will be having all these 4 members in it or all these 4 fields in it. Book 2 will also be having all these 4 fields in it. That's it. And you should remember that each member or each field should be ending with a semicolon. So that is how a structure is normally defined in C program. But there is another method of declaring the structure type also. That is the method, that is in that case actually what we do is we give a name to the structure type. So here we start with the struct, again the struct keyword is being used, struct, then there we are giving a name. It is in this case it is represented as tag name, tag underscore name, and then as usual we put the double braces, then all the members, member 1, member 2, etc., member 3, whatever be the number of members within that particular structure, all those members are defined here. Then we end the double braces as well as we end with a semicolon. So in that case what we do is we create a structure of type tag name. So if we are giving a particular name tag, say book, if we are giving a tag name as book, so we are creating a structure of type book. So that structure can be again used in a similar way as we define all other variables. So this particular part, this part is the structure type declaration. This is the structure type declaration. Then what we have to do is we have to structure variable declaration, that also we have to do. So when we are doing the structure variable declaration, it is again starting with the struct struct, then we are giving the tag name. Suppose we used the tag name as book, so it will be struct tag name, that is book, then variables list, the list of variables, that is book 1, book 2, book 3, etc., etc. So this is another method of defining the structures or declaring the structures. So in this case the advantage is that the structure is given a name. The structure that we are going to use, it is given a name. In the previous case the structure doesn't have a name, so we cannot say that it is when we want to comment something or give some comments, so in that case we cannot say that this particular structure is named this one. But in this case, in this particular type of declaration, we can say that this particular structure is of type structure, say book, So that way we can say. So that is again an easy to read situation arises when we use the structure definition like this, or if we follow the structure definition like this. So an example structure in this case, in this particular case, how the structure definition is being made and the variables of that particular structure are created. It is like this: struct books. So the only difference between the previous definition as well as this definition is that in between the struct keyword as well as the double braces we are giving a tag name. That is one difference. Then all the members within the structure is written here with the ending with the semicolon, no changes. Then we end the structure with a double braces. Till then it is okay. Then immediately after the double braces the semicolon ends, or the semicolon is put. In the previous type of definition or declaration, we put the variable names or the variable list in between this double braces as well as the semicolon. So in this case, actually this particular type of structure definition is done in two steps. The first step is we are defining the structure, we are defining or declaring the structure, then we are declaring the variables or defining the variables. So in the variable declaration part we are using struct books. So this is a structure and the name of the structure is books. So struct books, book 1, book 2. So this is another way of defining the structure which is easily readable also. That is, in this case it is easy to understand that book 1 as well as book 2 are of structure type books. If you want to comment, if you want to put a comment. And there is another advantage of this one is if the number of structures that is being used in the particular program is very large, if there are many number of structures that are being used within the program. So in that case, in order to identify what type of structure is being defined or being used at this particular position, so it is easy to give the names for that particular structure. Otherwise we may not be able to identify, or it may be difficult for us to identify what type of structure is being used here. So now how we will be process the structure variables? How can we process the structure variables? That is another aspect. So in the case of our normal variables or normal identifiers, we can directly assign the values, no problem, and a value from one variable can be copied into another variable, etc., etc. All those things can be, and the two variables can be compared, and all these things are possible in structure variables also. The members within a particular structure has no separate identity without the structure variable name. Suppose in the case of book structure, the structure that we described or defined in the previous slide, that is the book structure, the structure book. So in that case we have some 4 different members in that case. 4 different members were there. So that is number, title, author and price. You will not be able to access the title variable or the field title without using the variable name, the structure variable name. If you have 2 variables, say book 1 and book 2 of type, the structure type, that is book. So in that case, book 1 will be having all these 4 fields, as well as book 2 will also be having all these 4 fields. So if you want to access the title column of, or the title field of the first book, that is book 1. So in that case what you have to do is you have to first put the variable name, then a dot operator, that is a single dot, that is our full stop dot. So then you can put the variable name, that is like book 1 dot title. That in that way you can access the title of the first book, the title field of the book 1. So instead, if you are just putting it title, if you are putting only title, that way you will not be able to access the title of any of this book 1 or book 2, because it is an invalid variable. That variable will be valid only when we are using it along with the name of the variables also, the structure type variables also. So as such, the members are not valid variables. That is, the members are, all these 4 members are there, that is serial number, title, author and price. These are the 4 members within the variable book 1. So in order to access these members, you have to use the variable names also. So the link between the member and a structure variable is established using the member operator. That member operator is dot. As I said, we just put a single full stop there, that is, full stop is the dot operator, which is also known as the dot operator or period operator. So all these operators are, all these things are the same, that is, member operator, dot operator and period operator, all these 3 are the same. It is just a dot. So this operator is having the highest precedence among the various operators. So whenever you are having a precedence setup, this operator will be having the highest precedence over all the other operators. So the variable written as book1 dot number is used to refer to the field number within the structure variable book 1. So if you have a field like or a member like number, so within the variable book 1, so in order to access the particular number of the book 1, so then what you have to do is you have to put it like this, book 1 dot number. So if you want to access the number field of book 2, so in that case you should put book 2 dot number. So the variables written with the member operator can be used in expressions just like any other variable. So this way of representing the members can be used anywhere just like any other variable. So let's see some examples. So we will be discussing an example in which we will be inputting details of a student or details of students into a structure and then display the same details using the structures. So let us see how this can be used, or how a structure can be implemented in C program. So as always, we start with hash include stdio.h, then hash include conio.h, then we define 2 different structures. The first structure is struct date. So in this case, the second way of structure definition we are using. So struct is the keyword and date is the tag name, the name of that particular structure. This is important, this particular thing is important because at times you may have to use the structure inside other structure also. You have to use this particular structure inside another structure. So this is such a case. So in that case, if you doesn't give a structure name, then you will not be able to use that particular structure inside another structure. So in this case, this is struct date. So within the date structure, we have 3 members. Int day, so the day will be an integer value. Then month will be a character value, a character array, not character value, it will be a character array, and the size of the array is 10. So then there is int year. So year is another integer value. So in order to represent a complete date, we need 3 entities. One is the day, the second is the month, and the third is the year. And all these 3 things are inserted or included within the structure date. So structure date is a structure which has 3 members within it. Then we define a struct students, the students list, or the different students, the data for different students which we want to store, that is included within the struct. So this structure starts with again the struct keyboard keyword struct struct, then students, again students is the tag name. Then here there are 4 different variables or 4 different members within this particular structure. So that is, the first one is an integer, it is the roll number, so into roll number. Then char, a character array, char name 25, so the name of the student can be stored in this particular array. Then float marks, the marks of that particular student can be stored within this particular array, this particular field. So float marks, then struct date bday. So that is it. So this particular structure, this structure date is being used inside this structure, inside the structure students. The structure date is being used inside the structure students. So struct date bday. So bday will be the variable name, the field name for this students, and this bday will be of type struct date. So it will be of type date. So bday will be having all these 3 positions, 3 elements or 3 members in it. So this particular member or this particular field will be able to store the day, the month as well as the year in it. So this is how the structure can be used inside another structure. Then we end the structure definition with the double braces as well as the semicolon. Then we start our main program, that is void main. We start void main. Then we start double braces, struct students st1. So that is, we are defining or we are declaring a variable st1 as of type students. So st1 will be having all these 4 fields, as well as the last field, that is the bday, will be having all these 3 fields. So that is how it works. Then we are defining another structure variable, that is struct students st2. In this case we are initializing it in the program itself. So struct students st2 equal to, within double braces, 1402. So 1402, the first value, that is an integer value, and that will go into roll number. So the st2 dot roll number will be 1402. Then the name, the second value, it is an array, a character array, so it is a string, so it is a character array. So that will go into the name field of st2. Then the third one, that is 75.8. 75.8 is the third element, that will go into the field marks of the st2 student. So then there is date, bday. So this bday is having 3 fields. One is day, month and year. So the 15, this 15 will go to the first position within the bday field. So that is the first position or the first field within the bday field is day. So 15 will go to day, and March, this particular string will go to the month 10, that is the 10 is the size, so into the month. Then 1982, this is another integer that goes to year. So this is one way of initializing the structure variables within the program itself. And the second, or the first student, the st1, the first student, that we will input the value in order to initialize it, or in order to give values to it. So we put we display some message, input roll number of the student 1. So we have to put some integer values, and it will be stored in st1 dot roll number. See, this is how it is being accessed. The roll number of the first student is being accessed like this. So st1 dot roll number. So the ampersand symbol is required because we are addressing, we are accessing the address of that particular position or particular memory location. So st1 dot roll number, then puts input name of student 1. So we have to type in some character string or some string we have to type. So it will be scanned into st1 dot name. So we are accessing the name field of the student st1. So then we puts the display input marks of the student 1. So again some floating point value, some float value we are entering, so that will be stored into st1 dot marks. Then puts, that is we display that input date of birth of student 1. So in that case we have to put the date of birth. So see how this particular thing is being accessed, that you have to give importance. So in this case st1 dot bday is the bday field or the birthday field for st1, but within the bday field we have three different fields, that is day, month as well as day, year. So in that case, in order to access the day field within the bday field, you have to use two dot operators. The first is st1 dot bday, so we are going to the birthday field of or bday field of st1. Then within the bday field we want to go to day field. So st1 dot bday dot day. So likewise, if day also had some type of if day was also a type of structure, then you will be able to go to the element within that particular structure using the dot operator. So that way you can go to any level, but in simple programs we don't have to go to that much levels, only 2 or 3 levels is enough. So in this case we are going 2 levels down. So st1 dot bday, then dot day. So then the second one, st1 dot bday dot month. So this is the second one. So st1 dot bday dot month. So in this case we are not using the ampersand symbol. Why? Because it is a string. It is a string here. st1 dot name. Again we were not using the ampersand symbol. So because it is a string, we don't have to use the ampersand symbol along with it. So then another integer st1 dot bday dot year. So this is the three fields that is within the birthday or within the bday field, that is being input into the values or into the variables, into the different fields within the bday structure. Then we have to display all these things. Printf /n. So this is for new line, we are going to a new line. Then percentage %d, for space is allocated for displaying this particular integer value, the integer value roll number. In order to display the roll number, in order to display it in an aligned way, we want to display it in an aligned way. So that is why we are fixing the distance or the number of spaces that is being reserved for the decimal point. I mean decimal, not the decimal, the integer values, that is the roll number value. Then percentage %d, then /t. This /t is used in order to put a tab in between these two values, that is in order to separate it with a number of spaces. So that we will see. Then %s is for string, again /t %6.2f. so this is a floating point value or float type value. So in that case we reserve 8 spaces, a total of 8 spaces for the float value, out of which 6 will be for before this one and 2 after the decimal. And /t %3d, the other integer value. Then %t %s, this is for the month. Then /t, that is the tab character. Then %4d, that is for the year. So then you have to give each of the members or each of the fields that is to be displayed, the values of which is to be displayed along with these placeholders. So str1 dot roll number, so that is for this particular position. and st1 dot name for this percentage as, then st1 dot marks for this position, then st1 dot birth bday dot day. So st1 dot bday dot day. So that is for this percentage 3D. Then st1 dot bday dot month, that is for this percentage as st1 dot bday dot year. So that is for the last one. So likewise, in a similar way, you can put this is for the first student or st1, and in a similar way you can display or print the values of the student 2 also. The same procedure is being used. So now let us try it out how this is being worked. So compiled, no error. We are running it. Input roll number of student 1. I am giving a roll number of 4, 5, 6, 7. Then the name of the student. So I am putting Rahul. The name of the student I am giving it as Rahul. Then input marks of the student. Say the marks of the student is 87.98. Then input the date of birth of the student. Date of birth of the student, say it is some 23 February 1989. So let's run it. So see, 4, 5, 6, 7, this is the value that we have entered. The 4, 5, 6, 7, the name is Rahul, the marks is 87.98, and the date of birth is 23 February 1989. And the second value is same as the value that was input, that was given inside the program itself, that is 1402. The name is Arun 75.80, then 15 March 1982. So this is how we access the different elements within a structure. And in order to store the different values or different types of data, like the data of a student or like the data of a vendor, then in that case the structure is required. Without the structure we may not be able to process the data with accuracy. So that is the example that we were discussing. And now how we have to process the structure variables. So two variables of the same structure type can be compared just like the ordinary variables. So all the contents of a structure variable can be copied to another structure variable of the same type by a simple assignment statement, as we does in other type of assignment statements. Like if we have two structures, I mean the same structure, two variables of the same structure, st1 and st2, as in the previous case, st1 as well as st2. So if we have the values of st2, in that case we can directly give us st1 equal to st2. So this will copy all the values of st2 into st1. So all the contents of a structure variable can be copied to another structure variable. So some compilers like Microsoft C does not permit the relational operators on structure variables. So that is a difficulty. Some compilers doesn't permit the relational operators. So in that case, if the compiler doesn't allow the relational operations on the structure variable, so in that case the member by member comparison we have to do. So in that case the members are to be compared individually, that is we have to compare something like this: st1 dot number is greater than or equal to st2 dot number dot. So this way you will have to do. Otherwise, if the compiler permits the structure comparison, in that case you can directly give it as st1 is greater than st2. So this can be directly done. So in that case all the values, all the elements in the st1 should be greater than st2. So then it will return 1. So some examples of how the structures or the structure operations are being done. Consider we have two structure variables st1 and st2. So st1 equal to st2. So this particular statement st1 equal to st2 will copy the contents of the structure st2 to st1. The contents of the structure st2 will be copied to structure 1. st1 double equal to st2. It compare all the members of st1 and st2 and will return 1 if they all are equal and return 0 otherwise. So st1 equal to st2 means all the elements or all the fields within st1 should be equal with all the fields, all the corresponding fields within the st2. So st1 dot number number should be equal to st2 dot number. Likewise st1 dot title title should be equal to equal to st2 dot title. So likewise all the different fields are being compared in the case of this comparison, that is st1 is equal to st2, and this will return 1 if both are equal and 0 if they are not equal. Then st1 not equal to st2, so return 1 if all the structure members are not equal and return 0 otherwise. So this is how the structure comparison can be done. So let us now check in our program the way in which these things, the copying can be done or not. So we doesn't input the values, instead what we does is st1 equal to st2. Let's check whether this particular structure assignment will work in this particular compiler or not. So structure 2 st2 we have already defined, we already have values, so we are trying to copy the values of st2 into st1. So we compile it. So see, it is being copied. So the st1 as well as st2 are the same. st1 as well as st2 are the same. So now let's check whether the comparison works with the here or not. If st1 equal to st2, then puts equal. So we are just putting unequal there if both are equal. So in that case, so obviously we know that in this case these are equal if function, okay, we have to put, it should be put within the brackets. Sorry. Invalid operands to binary. Okay, that means this doesn't allow the comparison operator. So this particular compiler doesn't allow the comparison operator. Otherwise this would have been st1 double equal to st2. So in this case what you have to do is st1 dot number. So all the variables are displayed here. So roll number equal to st2 dot roll number. So in that case let's check. Yeah, oh sorry, there is a semicolon is also required here. See, equal. So equal in the sense that is the str1 dot roll number is equal to str2 dot roll number, and this thing, that is str1 equal to double equal to str2, this won't work. So there is an error, because this particular compiler doesn't support the comparison of two structure variables. So in that case you have to compare each variable or each element in the structure one by one. So that's it.